Hi, welcome to another video on my Raspberry Pi using Raspberry and Linux and streaming video once again. Last couple of episodes I have used this streaming video which has some 3 to 4 seconds delay, and this time it looked like it would not be happening, because each time I started the stream over the network, it stalled after a few seconds. This time it runs, so I keep it running. I hope it keeps running, and well, let's have a short recap of what happened last time. I have pulse width modulation. That is nothing new. What is new is that I am trying or started to try using the hardware pulse width modulation and the software pulse width modulation, because the motor is not running on software pulse width modulation and the LED is not running on hardware pulse width modulation. Then last time also it turned out that the wiring PI I had used previously would not work, because last time I used it was implemented in C and now I am using Python. So I had to reinstall it. Well, not reinstall it, I had to install it for Python. And last time it ended that it didn't work. However, when I look at the code here, I see I mix up, because although this is these lines are both commanding the GPIO to be used, this line is commanding to use the BCM version and not the board version. BCM implies that each pin is has its is using its GPIO number, and this is using its pin number. And what I am doing is using the pin number, so this one has to go. That's for one thing. Another thing that still worries me is the fact that, as you can see here, I am not running the program. And here on this circuit, and the circuit is fully active, as you can see by this LED, the motor is already running. Well, that is very weird. Anyway, with this small change, let's see if this LED here will run. And I have wired it to pin 7. So yeah, this is it. And again, I am afraid that this LED is not doing a thing. Now let me shine some more light on it. And you already noticed the delay. But once again, there is absolutely no light coming from the LED, and that's not nice, not nice at all. Alright, so what can we do? It is connected to pin 7. Yes, that it is. So what more can I do? It is possible, theoretically speaking, well, in practice also, by the way, that the wire is too thin to make any contact. And that's a problem. It shoots right high, so what I could do is measure the voltage over the wire for 3 seconds and then see whatever happens. So let's do that. Right. As you can see right here, I have put a taken a multimeter, set to voltage, and what I have to do is put the probe right here against one of the cathode, against the anode of the LED, and then see whatever voltage is over it. Right now it says 1.75 volts. And according to the program here, it says write high for 3 seconds and then write low and then wait 3 seconds. So I am watching the voltage to be changed, which I actually do not see happen. So that's a bit strange. The question is then, 1.3 volts could be enough for an LED to burn. If I measure here with this LED, which is burning, I measure 2 volts. If I measure here at the end of the transistor and I measure again, I measure 3.5 volts. Going back to the LED, which is supposed to be high for 3 seconds, I don't see anything happen. So I may be is this a wiring problem? I don't think so, because I do have voltage. So then it is the question, what is it? How does it work that way? And I think I should first quit this program and then say, alright, I will add some text to it. Print pin 7 high, and then understandably here print pin 7 low. Let's see what happens now. It just may be that I am thinking wrong again. Right, now I know what it should be. So once again, measuring with the probe at the LED. The whole thing again is low, so low is 175, high is 175 as well. That is strange. Alright, waiting for high is 175. Alright, so this means that the value apparently is not being written, because it's either 175 or 174, and the output set to high would be somewhere around 2 or 3 or something. So this means that something in this part of the code is not being is not really correct. Am I doing this correct? Here I am using GPIO. And this is using GPIO. Am I supposed to use this and this at the same time? That is a very good question. I think not. So in that case, this should be should stay commented. This should stay commented. This anyway. Then again, I have to investigate this once again. Alright, let's do that. I took a quick look at the code right here, and last time I figured out that I shouldn't use setup but to use setup sys instead. However, what I pointed out previously was that I was using, let me get to the code, I was using GPIO board, and here GPIO. So I am already using the GPIO in this case. It is commented out now, but when I use here setup GPIO for GPIO numbering, I think that is the way to go. So back to the code, not setup sys. Well, nothing prevents me from copying this line. Commenting this one out. And then say, okay, GPIO. Because that was the spelling was used. Yes. Now let's see what happens. Not much actually. So let's probe the whole thing again. And waiting for the high. Yes, it's still 174. And there's no resistor in between. Right, I thought I had it, but apparently not yet. It gives a voltage, but it stays that way. Now I can do actually the same trick again, which is then another wire back into the GPIO, and then deciding if this is high or low. But measuring this 175, well, comparing to the 3.3 volts, 175 is halfway. So I think actually this is being low, which is normal, because the LED is not working. What I can do, of course, is take it out and see if the LED works anyway. To do that, there's one simple remedy. Take this wire and connect it to this LED. That means actually connecting it to the output of this resistor. So here it goes. And lo and behold, there is the LED doesn't give in, shows nothing. But measuring here, it says 2 volts. Measuring here, it says 2 volts. And what does the LED do? I have to turn the light away for a moment. The LED does nothing. So, what if I replace the LED? Because this is not good. Alright, it should be put in like this. Hopefully this LED is functioning better. It doesn't do a thing either. And this is an oops. How do I know which works? Because now it really is this is odd. Oh, right. The ground was gone out, so now I'm measuring. I'm measuring 2 volts and the LED doesn't work. How can that be? I need to figure out the circuit, the electronics. I didn't expect that to happen. On 2 volts and 2 LEDs don't work. That's out of logic. Well, 2 LEDs tested and 1 LED was at the end of its life. At the start of the test it was burning, and 1 second later it was gone. Not gone up in smoke, but it just wouldn't burn anymore. While the other in 2 tests kept burning. So that's one thing. I already put it back in its place and it is not doing anything yet. You can see it right here. It's not doing anything, so I am going to replace these resistors by jump wire. See if that gives any change in behavior. I know it should not, but it should not, and whatever are two separate things. So, and guess what? Alright, this means that the resistors were too much. This also means that this change of 4 resistors with the jump wire was a very good idea. Now I am going to put the wire, this wire, back to the GPIO, where it, according to the program, should be. Now carefully put it back into 7. Then start the program and see if high indeed is high. And unfortunately I have to say that I don't see it happen yet. So I am measuring the voltage and it still says 1.7 volts at low. So I have to wait for the high. It says 1.7. High is indeed 1.7, not 174 or whatever. So this indicates that there is something not quite right in my assumption. Apparently, where this works. I still don't know. Let me put the wire once again back to this position where it gets its feed and the LED burns. It burns. So I have to look at both the code and, well, pin 7 is pin 7. There's not much discussion needed. Let me make sure that I indeed put it into 7. So, what's wrong? What is going wrong? I can stop this and yeah, let's take the code back, the example. Well, this is how I have to do it for GPIO pin numbering. Or sequential pin numbering. Am I mixing it up completely? Sequential. Okay, in case I mix it up. Just in case. let's do this. Sequential pin numbering. Alright, I don't mind. Let's do it. Ah, look at that. Yes, I did mix it up. High and low. Alright, I did mix it up. So, this means that first, software pulse width modulation and hardware pulse width modulation in one program does work. It also means that sequential pin numbering is what I was using, not GPIO pin numbering, and one says alright, and that is very confusing. If I say GPIO board using GPIO and then board, I use the sequential numbering, and if I use BCM I use the GPIO pin numbering. So here I use GPIO sequential, which is according to everything pin 1, pin 2, pin 3, etc. And GPIO means GPIO 17, which is pin number 31 out of my head. So these two lines I can delete. This is working. This LED very clearly shows it. Very clearly. But as far as the motor goes, I'm still at square one. So let's take a look at that. For the last part of this video, I am in doubt what to do. The software pulse width modulation intended for the LED, that is clearly this LED in the lower right part of screen, better indicated by opening the program. And here it goes. Yes, there you see it go, and it goes out again. That is software pulse width modulation, very nicely for the LED. Hardware pulse width modulation, not working at all right now. And that is not what I like. I've been trying for several episodes to get it working. It uses clearly the not the sequential but the GPIO numbering. Which is indicated here. This is GPIO numbering and this is sequential numbering as they mention it here. I am still using this. What I can do is take a look right here. So it says GPIO 17. Alright. Now let's take a look further back. BCM GPIO, that is the GPIO number, which is 17 being pin 11. So what they use here is pin 17, which for ease of use, ease for now, I am copying. Subcycle pulse, clear channel, So back to this. It's all the same what I do. And also I am, well, I could use 50, etc. You know, let me just do that. Whatever happens. Alright, and it. One last test. Let's start. Looking at the motor. Oh really? What's that? Apparently that it doesn't like. So this has to be 0. I'm fine with it. Any more problems? No. But what I like is a change of rotational speed. Still doesn't do that. And that is right now the end of this episode. Thank you for watching. Recap. Change in setup for the pulse width modulation for the LED. Changing an LED, testing it. Found that electronics had to be changed in order for the LED to actually work. But then pulse width modulation for the motor still doesn't work. What I want to do next time is see if the software pulse width modulation works for the motor, because last time I used it with C, and now I use it with Python. If you don't try it, you don't know, which certainly goes for this. If you like this video, please subscribe to my channel. If you don't want to subscribe, there's also I'm also on Twitter and on Instagram. Instagram, you have to copy and paste the URL to the video, and if you like my videos, please consider to make a small donation to keep this all alive. More info on my website, where you can also find my other projects and more information, photos, etc. And this is obviously going to be continued. Bye bye.